Hello everyone. So in this particular lecture we are going to understand the hydraulic pumps. So what is hydraulic pump? These are the mechanical devices that convert mechanical energy into hydraulic energy, and hydraulic energy is nothing but it is a pressure energy. How this pressure energy can be attained, we will discuss one by one from the classification of different hydraulic pumps. Okay, so the method to create hydraulic energy will classify the hydraulic pumps. So they are used to move the liquids from lower level to the higher level. So what is lower level? It is the lower level means the near to the earth, and to the higher level means uh, away from the earth. So it means we are going to take a particle from the earth to a certain height. So it is a work done against the gravity. Work done against the gravity. So gravity is the nature. If we do anything against the gravity, it means we must do work on the system. Means the hydraulic pumps are work consuming devices. Work consuming devices that we have discussed already uh, in the short form like WCD. So how the energy transform from the electrical energy to the pressure energy, we will discuss one by one. Like electrical energy is provided by the electrical supply to the motor. Motor provide a rotational kinetic energy, which is given to the shaft, which is once again the mechanical energy. So the rotational energy from the motor is receiving the energy from the electrical supply, and that electrical energy is converted into the mechanical energy, and this mechanical energy is giving a motion to the water particle or liquid particle. Here we are talking about the hydraulic pumps. So hydraulic pumps means it will deal with the water, and then this water will attain a certain amount of velocity, and we know that from the Bernoulli equations that the P upon rho g plus V square upon 2g plus height, that is z, must be constant. The summation of pressure energy, velocity and kinetic energy and the potential energy must be constant. This is also nothing but it is a conservation of energy law. So if the velocity of the fluid particle increases, then pressure must be decreases, and this pressure difference is the pressure energy. Okay, so the electrical energy converted into the kinetic energy, and finally it converted to the pressure energy, which provides the lifting of the water from the lower level to the higher level, that is against the gravity. So which what kind of energy we have supplied for this purpose? We have supplied the electrical energy. So this is a work consuming device. So this is all about the introduction of the hydraulic pumps, and slowly we will move towards the classification of the hydraulic pumps. So in this particular lecture we will discuss only the first kind of hydraulic pumps, that is the centrifugal pump. So what is the application? Everyone knows about the hydraulic pumps. Everyone having at their home that kind of motor. We often call it like motor, but motor is not the real name of that particular device. The motor is an integral part of that hydraulic pump. Motor is just an integral part. which provides a rotational kinetic energy to the inside part of the, I'm not giving the name right now, we'll discuss later on. I'm not giving that part. And that particular kinetic energy will be provided to the hydraulics, means water, liquids, that will further decrease the pressure at that point. So the application is water supply and irrigation system, cooling and lubrication system. Nowadays in the modern advanced mobile phones, there are micro pumps inside that to lubricate the phone at a high performance, for the high performance, like so many students are doing gaming, so in that case we have to cool down our devices. So in that but small devices, we must have a pump which supply the lubricant throughout the body of the phone. So hydraulic machineries and power transmission, as we know that so many cranes are also working on the fluids which are being pumped from the motor and hydraulic pumps. Hydraulic pumps, we can't say like hydraulic pumps only, because it is only deal with the water. So the topic is hydraulic pump in the basic mechanical engineering. So the domestic overhead tank water lifting is also using the hydraulic pumps. So I can draw some diagram for the domestic hydraulic pumps. So we have overhead tank. Overhead tank means it is above your head, and there is a pipe which is known as a delivery pipe, and there is a groundwater in which water at a certain height from the ground level, at the beneath of the earth's surface, just below, and in between them there is a pump. So I'm not drawing the actual diagram of the pump, just this is as an indication of the pump, and there is a pipe from the ground level to the pump. This is known as suction pipe. This is known as delivery pipe. This is pump, and this is tank, storage tank. Not storage tank only, this is also to supply the water, so it is known as a reservoir, not a tank. And at the bottom, this is known as sump. Okay, so these are the basic components of any hydraulic pumps. So in upcoming slides, we see the classification of these pump types of hydraulic pumps. The hydraulic pumps are broadly classified into two main types. First one is the centrifugal. In this particular lecture we will see the centrifugal pump, and in the next lecture discuss we will discuss reciprocating pump. So what is reciprocating pump and centrifugal pump? In centrifugal pump, the kinetic energy is in the form of rotational kinetic energy. Centrifugal, when the centrifugal force comes when there is a rotary motion in any object, then in reciprocating motion, to and fro motion, means left, right, or up and down, the motion is known as reciprocation or to and fro. Okay, and it is a high pressure and low discharge application. It is for the high pressure, means the speed of the discharge is very high, but discharge, the amount of the water per second to be lifted up, is very low. And the in the reverse, for centrifugal pump is at a low pressure but high discharge. With a high discharge means the flow of the water is low but amount of the water is high. So the real diagram of these two pumps are as shown in the figure. Like this is the pump, actually this is the pump, and this is the motor. The motor is an integral part, so that the 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 component inside the pump can be rotated, and this rotation pro, uh, this rotational kinetic energy is transferred to the fluid. The fluid is hydraulics, means water, and that water will get the kinetic energy, and hence its pressure will decreases, and the pressure difference will cause the water lifted from the sump to the pump. As you can see here, the water, if the pressure here is decreases, then the water at a ground level, at a atmospheric pressure, it provides the lifting of the water from the ground level to the pump. And we'll see in the upcoming slides that how this water lifted further upwards to the water tank. So as you can see, this is the motor which is aligned with the shaft of the pump. In case of centrifugal pump, this is the mostly at a domestic level we are using this kind of motor, sorry, pump. And here the pump is in this particular direction, the shaft of the pump is in this direction, and the pump is in this direction, means the perpendicular. Okay, so the detailed explanation will be in the next lecture. Priming. So before we start a pump, we must do priming. Means whenever we purchase a pump, then we have to maintain the priming phenomena. Means what is priming? At the start, there is there is a air in between the sump to the pump. So the density of the water is 1000 kg per meter cube. But what is the density of air? Air density is 1.02 kg per meter cube. Means the density of the water is 1000 times the density of air. It means the pump cannot lift up the air if air is filled into the suction pipe. So we cannot connect this water to the pump. We cannot connect this water to the pump because there is a air. So we have to remove this air, and this phenomena of removing the air by filling the water into the suction pipe is known as priming. Okay, so the it is in the third stages, like as you can see in the first diagram, there is no water in the suction pipe, and when once we fill it from the priming valve, liquid is filled it in the pump, then there is a connection in between the sump and the pump. Okay, and then we can remove out all the air from the suction pipe, and the connection will take place, and the water will supply from the bottom to the top level. So I have already discussed what is priming. So why priming is necessary? As I have given the 2 points, air cannot be pumped by centrifugal pump. Without priming, the pump will not lift water, may get damaged. Means if we do uh, uh, switch on the pump for long period of time and there is no lifting of the water from the ground level, then the pump can be damaged, because it is going to be warm up, because there is no water to cool down the pump, hence the pump can be damaged. Method of plumbing, as we have seen, the manual filling of the water using a vacuum pump, so that we can remove out all the air using a foot valve and filling through the delivery line. Now we must understand the centrifugal pump, first pump, that is centrifugal pump, the working principle. Now, what is the working principle of this pump? So as from the name of the pump, centrifugal, The centrifugal pump works on the principle of centrifugal force. And how we get the centrifugal force? The centrifugal force, that is Fc, is equals to mv square upon r. What is r? R is the radius of any fluid particle which is away from the center of the rotation, and the mass of that particle, and v is the velocity, linear velocity. And that this will provide the centrifugal force which is always away from the center, always away from the center. As you can see in the making the butter from the milk, whenever we rotate, stir, whenever we stir any from any wooden stick, then we can see that the butter, that is the hard particles of any dairy products, and it will stick out from the center to the wall of the any utensils. And how this conversion takes place, as we have discussed in the hydraulic pump, same here in the centrifugal pump. Only the difference is this mechanical energy will be a kind of kinetic energy. And what kind of this kinetic energy is? The rotational kinetic energy. If this is a rotational kinetic energy, and this attained from the centrifugal motion, centrifugal motion, then the pump is known as centrifugal pump. Okay, so this kinetic energy must be a rotational kinetic energy, and this kinetic energy will be generated from the centrifugal motion of the pump. The pump, then the pump is known as centrifugal pump. The principal statement, what is the principal statement? We can write, when a mass of the liquid is rotated by an external torque, it is thrown outward under the action of centrifugal force. This outward flow, increases the liquid pressure at the wall of the pump. Means the liquid is getting thrown from the center to the wall of the pump. So the gathering of the fluid particle takes place at the wall. So many fluid particles is gathering, so pressure is gradually increasing at the wall, but decreasing at the center, because there is no fluid particle if they have been thrown out. Okay, so there is a pressure difference inside the pump. Okay, so we will discuss from this diagram. Whenever this is eye of the impeller, and there are blades, which blades are known as impeller. Okay, these are the blades. And this is the strainer. As you know that this is the ground water, so there may be some impurities, and stone particles are there, sand particles are there, so there must be some strainer. There is a footwall can be opened automatically if the pressure is low at the pump, but uh, the pressure at the sump is high. Now, what is the pressure at the sump? It must be, a atmospheric pressure. Okay, it is a atmospheric pressure. Hence the motion of the impeller created a pressure below the atmospheric pressure at the inlet of the pump. So if I say, here it is P1, here it is P2, here it is P3, and at the overtank it is P4. Okay, so overtank is also is exposed to the atmosphere, and this ground level water is also under the atmospheric pressure, as we have digged out a hole into the ground. So we have atmospheric pressure at the ground level also. So P1 equals to P4, and it is equals to P atmospheric. Okay, so what is the relation between P2 and P3? Which is more? P2 is greater than P3, or P3 is greater than P2? Which is correct? We must think about it. This is HS, suction head, This is HD, delivery head from the pump to the overhead tank. And what is HS? HS is the sump to the pump distance. And the total H is HS plus HD. Total head is HS plus HD. So whenever the impeller start rotating, so the fluid particle which are near to the eye of the impeller will be thrown out towards the wall of the pump. Then there is a lag of fluid particle at the center. Then the pressure will decreases at the inlet. Okay, so P2 is lesser than P1. Hence, the fluid particle from the sump will lift it towards the pump, and then the fluid particle thrown out towards the wall of the pump. Hence, there is a gathering of the fluid particle which are not going to be delivered to the over tank until unless this delivery wall is opened. This delivery wall. So the gathering of fluid particle taking place continuously, and at a certain point the pressure is much more higher, so that this delivery wall is opened. As you can see, this P3 must be greater than P4. Why? So that this water fluid particle will flow from the pump to the overhead tank. So P4 is must be less than P3. So there is a relation between P2. P2 is less than P1. P3 is greater than P4. But P4 equals to P1. Okay, and this is also greater than P2. So we can write like that. This P1 is greater than P2, and P3 is greater than P4. Okay, so this relation can be taken place. And there are some certain components which are very important, that delivery wall, the suction flange, suction pipe, delivery pipe, sump, strainer, foot wall, and the overhead tank in the eye of the impeller. This is the impeller, and this is the casing. What is the function of the casing? To save the impeller from the environment. These are the function, and the important components are written mentioned over here, and you can understand all the components function from these points. And working we have already understand from the diagram. We can write one by one. So now, what is power required for a pump to lift from the HS to HD, from the sump to the overhead tank? So I'm going to make a line diagram of the pump. This is the overhead tank, so this is a delivery head, HD, this is HS. So I'm going to write the power formula for the pump. P is equals to the density of the water multiplied by Q. Q is the discharge, G the acceleration due to gravity, and H the total head. And we can write like, what is rho? Rho is the density. Q we can write area, not area here. Area will be considered in the reciprocating pump. Here it is the Q. Q means volume per second. G or and H we can write in the form of HS plus HD. What is Q? Q is the volume flow rate, or we can say discharge, and the unit is meter cube per second. Unit of this Q is meter per second. Small g is and I have already mentioned all the parameters. That is, this is the power in watts, rho density of the liquid, kg per meter cube, q is the discharge or volume flow rate in meter cube per second, g is the acceleration due to gravity 9.81, and h is the total head developed by the pump, that is equals to hs plus ht in kilowatt divided by 1000. P equals to rho qgh divided by 1000. So we will get the answer in the kilowatt. The last, the cavitation. What is cavitation? As we know that the pressure at the inlet is lower than the atmospheric pressure. Pressure at the of the pump, inlet of the pump is lower than the atmospheric pressure. So whenever pressure is lower than the vapor pressure of the liquid, then boiling of the liquid takes place. It means boiling of the water at a room temperature or atmospheric temperature atmospheric pressure is 100 degrees Celsius. But if we increase or decrease the pressure, this boiling point can be changed. Okay, so if the pressure is lower than the vapor pressure, if the atmospheric pressure is lower than the vapor pressure of the liquid, then boiling will take place. So at the inlet there is a chance of boiling, because at the inlet we need the pressure to be lower than the atmospheric pressure. So it can be lower than the vapor pressure of the water. So there is a possibility of boiling. Now, what is boiling? Whenever boiling takes place, there will be a formation of bubbles, and bubbles are at a high velocity which form at the near the surface of the impeller. Okay, so these bubbles will get collide with the impeller blades, which is at a very high velocity, which causes the erosion of the blades. Erosion means, what is corrosion? Corrosion means chemical reaction, the removal of the material due to chemical reaction. But what is erosion? Erosion is the removal of the material because of mechanical action, means force, pitting, pitting. Okay, so it is also the phenomena of removal of the surface material, but because of mechanical action, because of mechanical forces. So this causes a cavitation inside the centrifugal pump. And what is the location of this cavitation? The prompt location, means which is very likely to be eroded. It is inlet of the pump, because the lower pressure can be happen at the inlet, okay, as we required it. So this pressure must not, this must be less than the atmospheric pressure, but must be greater than the vapor pressure of the liquid. Okay, so the pressure at inlet must be less than atmospheric pressure but greater than vapor pressure. Okay, so what are the causes? I have already discussed. The low suction head, high temperature of the liquid. So high temperature will causes the bubble formation, air leakage in the suction pipe, blocked suction filter. Blocked suction filter reduction means, blocked suction filter means low fluid particle to be passed to the fluid, and hence causes the low pressure inside the pump. So what are the effects? The reduction in the pump efficiency, vibration and noise, pitting means erosion of the impeller, and flow instability. Instability means sometimes the flow is high, sometimes it is low. So uh, these are the contents from the centrifugal pump. I think all of you have understand it. Write your comments in the write your doubts in the Google Classroom, so that we can discuss for the same. And you can try these part A, part B, and part C questions. In the part C, I have added a numerical kind of problem, which is very simple. You can use the formula ρQgH divided by 1000 to find out the power in the kilowatt, and you can try these theoretical problem. First is the memory based, and second is the some kind of understanding, on the basis of understanding, and last one is on application.